Welcome back to our discussion of unitary and orthogonal operators. We have already discussed some properties, definition, and some key results related to unitary and orthogonal operators. Now, this lecture will be started by discussing an example and then we will prove some result as well. So, this is example नंबर टू एंड कुछ एग्जाम्पल्स ऐसे होते हैं जो हम बार बार डिस्कस करते हैं सो यू शुड अंडरस्टैंड देयर इम्पोर्टेंस कि उनका हर डिस्कशन में किस तरीके से एक सिग्निफिकेंस रोल है वो हमें आइडेंटिफाई करना चाहिए सो अगेन आई एम टेकिंग एन एग्जाम्पल दैट वी हैव ऑलरेडी डिस्कस सो लेट टी be a linear operator from r square to r square, okay, and this is the rotation be a rotation by theta, and where theta is between 0 to pi, not including 0 as well, pi. Now then prove that. First we will have that t is orthogonal. Okay, so I'm writing the solution of each question. So if t is rotation, so suppose we have this r square, this is our r square, and suppose that this represent the t. Suppose we have some vector v here, this vector is v, okay, और हमने इसको रोटेट कर दिया है by angle of theta. Suppose now this vector v is at this place, okay, so this angle is theta, and now we have this vector and that vector is t of v. So we have rotate, this is our v, and we have rotate this v by an angle, and then we are having the t image of this vector v. तो अब इसमें आप ये देख पा रहे हैं कि v की पोजीशन चेंज हुई है बट उसका लेंथ सेम ही है. वी आर जस्ट रोटेटिंग द पोजीशन ऑफ ईच वेक्टर इन आर स्क्वायर. तो यहाँ पर लेंथ में तो कोई फर्क नहीं है. सो व्हाट वी कैन राइट दैट सिंस t only rotates each vector in r square by an angle of theta, where you can say thus t is orthogonal operator. ठीक है. Now come to the second part. It says T preserves the perpendicularity of any two vectors in R square. ठीक है. ये सभी हम ज्योमेट्रिकल देख ही सकते हैं. कैसे? अगेन सपोज वी हैव दिस आर स्क्वायर and we have, suppose this is our vector v1 and take a perpendicular vector. So this is our v2, okay, this is v1, this is v2. So we are saying that v2 and v1 are perpendicular. Now if you apply the t image on v1 and v2, suppose after rotation by theta we have v1 at here, okay, this is by rotation theta. So this is our t of v1, and when we rotate this by theta, suppose we have this one. So this is also theta and this represent the T of V2. Okay. So again you can see the angle between these green lines is same as the angle between V1 and V2. Okay, white lines. So अगर V1 और V2 perpendicular है तो इनकी T images भी आपस में perpendicular होंगी. So that implies that T of V1 is also perpendicular to T of V2, right? So you can see हमने ये भी देखा था कि जब T orthogonal operator है so it preserves the inner product also. So let me write that since perpendicular हमें दो वेक्टर कंसिडर करने हैं. So let V1 and V2 is in R square such that inner product of V1 comma V2 is equal to 0. That means they are orthogonal or perpendicular, right? Now what about their T images? Okay, since in inner product of V1 comma V2 is same as inner product I of V1 comma V2. हमने लास्ट लेक्चर में जो थ्योरम्स प्रूव की थी वहां से मैं टी टी स्टार को आइडेंटिफाई कर रहा हूँ. ठीक है, इस आई को हम लिख सकते हैं टी स्टार टी ऑन वी V2. ओके, ये क्यों लिख पा रहे हैं? सिंस टी इज ऑर्थोगोनल which implies that t star equals to t star t equals to I. ये हमने प्रूफ किया था. ठीक है, and that will be equals to t of v1, this is v1, comma t of v2. Now if this is this inner product of v1 and v2 is same as the inner product of their images, so you can write therefore this inner product t of v1 comma t of v2, that is equals to inner product of v1 comma v2 and that inner product is 0. So this implies that t of v1 is perpendicular to t of v2. So this is the what do we mean by preservance of perpendicularity of two vectors. Now the third question is as follows: T is not self adjoint. ये हम already prove कर चुके हैं. ठीक है, so you can write this solution as follows. So let beta be the standard ordered basis for R square. Okay, then we know that the matrix A, which is the matrix representation of T in beta, that is given by cos theta minus sin theta cos theta. Now each value is real, so you can write A star is equal to, that is the T beta star, which is equal to T star in beta, and that can be simply cos theta. We just need to take the transpose only क्योंकि सारी entries real है, minus sin theta cos theta. Okay, now for theta belongs to open interval 0 to pi, this A star is not equal to A, right? You can see थीटा की इस रेंज के लिए ये कभी भी आपस में इक्वल नहीं होंगी. सो दिस implies that t is never equal to t star, and that is implying that t is not self adjoint. Okay, now come to the fourth part of this question. It says prove that t preserves the inner product on R square. तो R square पे हमें पता है inner product is the component wise product and then addition. So let me write the solution. Now we know that T is orthogonal, so we have the following discussion, that is T is orthogonal operator, therefore we have inner product x comma y is equal to inner product t of x comma t of y. Okay, you can verify this also. How? Since as you can see, as ये हमने प्रूफ किया ही था, t of x comma y is equal to t of I of x comma y, and in place of I you can write it as t star t on x comma y, and that is equals to t of x comma t of y. ओके, यही हम क्यों लिख पा रहे हैं? सिंस t स्टार t एंड t दिस इज इक्वल्स टू I, क्योंकि ये ऑर्थोगोनल है, इस वजह से हम लिख पा रहे हैं. ठीक है, सो t preserves the inner product. ठीक है, now come to the last one, and that is find t star. What is the adjoint? That is adjoint of t. ठीक है, so अगर हम इसको by just looking at the matrices, we can write that since a star, what is a star? That is equals to cos theta minus sin theta cos theta multiply by cos theta sin theta minus sin theta and cos theta. You can see cos theta plus sin cos square theta plus sin square theta, then you have sin cos minus sin cos. So you can verify 1 0 0 1, we have this matrix. And what about a star a? That is equals to cos theta minus sin theta cos theta, and then we have cos theta minus sin theta cos theta, and again you can verify that this is identity matrix. Okay, so a star a is equals to I, and this implies that that is also equals to a star. This implies that t star t is equal to I, that is equals to t star, and this implies that t star is nothing but the t inverse. Okay, now what is t inverse? Where t inverse is rotation by minus theta angle. ओके, तो अगर t थीटा एंगल से रोटेट कर रहा है तो t इनवर्स माइनस थीटा एंगल से रोटेट करेगा, और यहाँ पर हम देख पा रहे हैं t स्टार इज द इनवर्स ऑफ t. ओके, सो दिस इज आवर t स्टार.